In this video, we're going to look at describing a solid using spherical coordinates. So they give us a couple of inequalities. The first one is rho is less than or equal to 2, and the second one is that rho is less than or equal to the cosecant of phi. And we're asked to sketch the solid that satisfies both of those conditions. Well, the first one's pretty straightforward. If we have rho is less than or equal to 2, remember rho is representing distance for the origin. So if we want all the points that are a distance of 2 or less to the origin, then we're talking about the sphere, solid sphere, that is centered at the origin and has radius 2. Well, let's look at the other equation where we have rho is less than or equal to cosine phi, or cosecant phi, pardon me. Remember your phi angle is always between 0 and pi, so your cosecant and in turn your sine will be always positive. So if I multiply both sides by sine of phi, it will not flip the inequality. I would need to worry about it, of course, if it was actually equal to 0 and changing what the inequality would say, but if it's equal to 0, then the rho is equal to 0. All right, to put this in a form that we can actually recognize what it needs to be, let's play around with this a little bit algebraically. Let's square both sides. That doesn't change the inequality. And certainly rewriting that rho squared sine squared phi times 1, that's not changing anything. But I can cleverly rewrite 1 as cosine squared plus sine squared. So this, actually, I knew where I wanted to get to, which is why I started by squaring both sides. I want to get this written, 1 written as cosine squared and sine squared. So I needed to have a square on both my rho and my sine squared, on my rho and my sine of phi, so I could pull out a squared here towards the end. So then distribute and pull out the square. We get rho cosine theta sine phi squared, and then a rho sine theta sine phi squared, add it together. And now we recognize these expressions inside the parentheses as x and y respectively. So we get x squared plus y squared is less than or equal to 1, which is the cylinder, this gray cylinder that we see here. So these two inequalities together represent the solid piece of the cylinder that lies inside the sphere. Or said maybe even a little bit better, I could imagine drilling a hole through the sphere along that cylinder, and it's actually the hole that's what I'm interested in. This would describe the hole that I drilled if I drill along that cylinder.